So on number 1, it's just asking us to describe the given relation using either the roster or the set builder method. Well, since it's just a bunch of points, we can just list the points. So that first point is -4, -1, and -2, 1, and then 0, 3, and then 1, 4. Let's look at another one. For number 2, so we kind of have to parse this. So this one we're going to have to use the roster method, and the reason is there's an infinite numbers, right? Like just the fact that it's a solid line all the way through like that tells me I'm going to have to use the roster method because I can't list an infinite number of numbers. We just can't do that. So that means that it's going to look something like this, and then I have to explain what my x and y are. Well, the first big hint is that if you notice, this is y equals 3. My y value has to be 3. So immediately I can make my y value 3. Now my x value seems to have a bunch of different things going on. So I'm going to have to tell or state what x is doing. And it seems to be starting with 3 or -3. So it's starting with -3, and then that -3 seems to be, or x is, I wrote that backwards. So it seems to be that x is greater than that -3. That -3 is the smallest value. It's a closed circle, so that's why it's equal to, and x is greater than that -3. It's greater. It's going to infinity. Let's look at another one. So for number 3, same idea here. Because it's solid, there's an infinite number of numbers. It seems to be that the x value has to be 2. Now my y value, it's changing. Now we can define what my y is. Well, it seems to be starting at -3. So y is greater than that -3 since it's going up forever. Now it's an open circle, so that's why I didn't do equal to. Let's look at number 4. So for number 4, it is a little different here because it's not like a line, right? So because it's not a line, that means we're not specifying what my x or what my y's are. It does seem, though, that my x value is shading forever this way. So there are no restrictions for my x value. But my y value seems to stop here and go up forever. So my only restriction is my y, and it seems like y has to be greater than or equal to 0. But my x are all positive or negative. It goes on forever that way. It goes on forever that way. There are no restrictions for my x. So that's going to be my set. Let's look at one more. So for this one, same idea. Because there's a bunch of there's a shaded region, it seems it's going forever that way. It seems it's going up for that way. There's nothing in the negatives, though. So x is going to be greater than 0, and y is going to be greater than or equal to 0. Now, the reason why I say equal to is there's no dotted line. So that's number 5. All right, for number 6, it says find the distance d between points in the midpoint of the line segment that connects them. All right, so remember the distance formula. So you just plug in the points. -7 minus -2 squared plus -7 minus 3. So add, so you get -5, -5 squared is 25. You get 10, so you get the square root of 125. You can break that down. So you get 5 root 5. And then the midpoint, you add them together and divide by 2. So the midpoint, add them together, -9 over 2. 3 and -7 is -4. You can simplify that to -2. For number 9, reflect the point. So if I have the point A, -4, if I want to reflect that over the x-axis, you add a negative to the y, so you get A4. If I wanted to reflect that over the y-axis, you add a negative to the x. And the origin, you add a negative to both. And then graph the following. For number 10, x is -2, meaning you want to cross it through, -2. And number 11, I'm going to do in red. It says y equals -2. So that's going to be a horizontal line at -2.